Dear colleagues, it's a real pleasure for me to welcome you all to this international workshop to present the results of the project Bioplat EU. Allow me to thank the whole consortium of the partner of the project, WIP in particular as coordinator, and each and every partner of the consortium for the very positive and constructive cooperation spirit during the last 3 years. It has been a long way together. Allow me also to thank the GBEP colleagues that are connected in this international workshop, as well as additional participants and colleagues and experts for joining us today. Well, the overall objective of the project has always been, since the very beginning, to promote the market uptake of sustainable bioenergy in Europe, using marginal, underutilized, and contaminated lands for non-food crop biomass production through the development of a web-based platform that serves as a decision support tool. Well, we are very pleased for the excellent results of the project, for the concrete added value of the developed WebGIS tool that supports the sustainable development of bioenergy on marginal, underutilized, contaminated lands in Europe and neighboring countries. We are also very pleased for the positive feedback that we've already received by the international community on the results of the project on the application of the WebGIS tool. That represents, of course, a fair credit to the work, to the hard work and efforts that have been made by each of us in the consortium in the project. It is also worth mentioning that this project has been the natural continuation of a previous Horizon 2020 project in which we have collaborated together, which is the FORBIO project. That was also the first Horizon 2020 project for our team in FAO. So both projects stem from the legacy of the GBEP sustainability indicators and represented two important test benches for the application of the GBEP indicators to different scenarios, to different circumstances with respect to their initial intent. So these two projects have allowed us to develop important conditions, policy recommendations, and tools for a sustainable bioenergy development in the region. And the link with the Global Bioenergy Partnership and this community is therefore extremely strong. So again, the Bioplat EU project is giving us a very high level of satisfaction and positive feedback, and I'm confident that the WebGIS tool will be and is already a concrete support to decision-making in the bioenergy sector in Europe, contributing to achieve the requirements of the European directives. And with these, I would like to leave the floor to Rainer, and I wish you all a very good workshop. Thank you so much.
Yeah, thank you very much, Michaela, for the kind words, and welcome to all participants of our international workshop. I will not repeat all what Michaela said, but I do want to also repeat thanking all partners for the excellent work during the past 3 years. I think we have very fruitful results to show, and I would also like to take the opportunity to thank my colleague Cosette Ravaja for the excellent coordination of the Bioplat EU project. So I think all partners together with the good coordination made the success of this project. Actually, for today in the workshop, no, maybe one step back. We all know that the policy sphere is moving in Europe. I have some sort of detailed information, but also globally. However, sustainability will always be at the core of a biomass provision. We do know that the sustainability requirements for biomass, different kinds of biomass for different applications, are currently under review on European level. However, biomass sourced from so-called MUC lands, as Michaela was saying, marginal, underutilized, and contaminated, they will most likely receive a special treatment, let me call it like that, under the EU regulation, meaning that such feedstock can continuously be used for biomass, bioenergy applications or applications in the overall bioeconomy. There, as we found in the project also, it is identifying these areas is not very easy. So we can acknowledge, I think, the work again of the Bioplat consortium of being one of the first initiatives to make a concise European-wide mapping of such lands. Plus, and this of course was quite complicated, but is an excellent achievement, linking those lands immediately with the already mentioned GBAP sustainability indicators. So other than sort of very simple assessments, we don't really only calculate hectares. So the identified hectares through GIS system, they are the starting point for moving forward with respect to sustainability considerations. I will not try to summarize this issue. I assume that most participants are aware of your GBAP set of indicators, and rest assured that these were a good starting point for the further work by our FAO colleagues. So we are very happy that today actually, so the web-based platform is online already for a few months, has already been tested by a number of experts. And very happy that today we'll be able to give you a number of kind of summary presentations on the project work. Namely, my colleague Cosette will give you an overall overview on the whole Bioplat EU project. Colleague Manuela Hirschmugel from Joanneum Research will give you more insights about the mapping itself from MOOC lands using remote sensing, which was kind of the starting point, as I mentioned, to identify these MOOC lands. Then Lorenzo from FAO and Alfonso Calera from UCLM in Spain will provide you with some details on the developed web-based platform. And I'm sure that you will, in the end, agree with all of us that it's quite an elaborated work of arts that was developed. After a short break, Marco Colangeli, also from FAO, will demonstrate the WebGIS tool, because after all, it is now the users to make full use of the tools. Later on, we will try, even in this hybrid format, to facilitate some interaction with you. So don't be shy, ask any questions you have. And then Michela will give maybe an outlook with respect to potential future activities or the synergies with the Global Bioenergy Partnership will also be much appreciated. Good. So with this introduction, so I hope you all look forward to this workshop. I would pass over to my colleague Cosette, which means that I say goodbye and Cosette will fly in.
Good afternoon, everybody. Thank you, Michela. Thank you, Rainer. And I have put the screen now with all the colleagues because it is a hybrid event and it's our first. So it's a bit, it was a bit challenging in the beginning, but now we are under control. Hopefully we won't have any more technical problems. So from my side also, I would like to thank the consortium, the Bioplat EU consortium, and also all the GPAP community and other stakeholders that are attending the event. I will, from my turn, I will give you an overview, a general overview about the Bioplat EU project without getting too much into the details, because you will have them, as Rainer said, with the respective colleagues. I will try now to share with you my screen. Okay, so I hope that you can see well. So the Bioplat EU project, it's an EU-funded project. Sorry, yeah, it's an EU-funded project that has started since November and it will come to an end next month. It is the cost, the estimated project costs were around 2.5 million euros, and it is coordinated by WIP Renewable Energies. Alongside, of course, with WIP, we have a lot of experts from different organizations and from different countries. Due to them, we were able to implement this very like not easy to implement project, let's say, challenging project. So we have the FAO, Leonardo from Hungary, Ioanneum Research from Austria, FIB from Germany, CREA from Italy, Scientific Engineering Center Biomass from Ukraine. From Spain, we have UCLM, Enero from Romania, ELO from Belgium, 123 Capital from the Netherlands, and the industrial partner Neste. So how the idea of the Bioplat EU came into life. So most of the participants are aware that the bioenergy plays an integral role in order to reach the European EU climates, which are for 2050 zero emissions. And also bioenergy is support the SDG goals in the context of climate change and energy security. And also it is believed that it will, we need bioenergy also to reduce global warming, as it was reported in the IPCC report recently. But this is true, but only this is applicable if the biomass that is produced is sustainable. And this is really very important. On the other hand, we have in Europe, at least, a lot of marginal, underutilized, and contaminated lands that could be suitable for these bioenergy production, because there are no competition on food and feed. So there is no let's put it like this, competition. And so it would considered as a win-win situation for bioenergy production and for making use of these unused lands. And this is how the Bioplat EU project came with. The objective is to promote the market uptake of sustainable bioenergy production on these MUC lands. And this is done basically by developing a web-based platform that includes a tool, and it is considered as a decision support tool, because this tool will give first insight about viability and sustainability of selected bioenergy value chains. So the main activities of the project include, as I mentioned earlier, is this web-based platform. So this platform is made of, let's say, two main parts. The first part is it's a website which includes information about the project, and a help desk which can support stakeholders with our experts that are present. They can address questions and we will answer them. And the WebGIS tool, which is composed of mainly two parts: the GIS maps, where you could see the underutilized and contaminated lands on a map visually, and then the STEM tool, which is the sustainability tool for assessing the sustainability indicators. So here I wanted to show you how the Bioplat EU platform looks like. And then we have here, as I told you, all information with news, everything. And then here we have the WebGIS tool. So if you click on the WebGIS tool, you will be directed to this wonderful tool. So in this tool, of course, later my colleagues will explain in more details. But as you can see, we can visualize the MUC lands. And then we could select a crop, a value chain, and then we do a sustainability assessment. So this is the first part of the project. This tool was done, but of course, in order to make it significant and really applicable, we needed to see whether it works on real case studies. So this was another part of the project where we had to apply the tool or use the tool on real case studies. And we had 12 case studies in Spain, Italy, Ukraine, Germany, Romania, and Hungary. And this, of course, has helped us to fine-tune the tools where it was not working well. We had added features to that and helped a lot in the optimization of this tool. Okay, so now we have the tool, it's optimized, very good. And then the next step would be, of course, to make the people know about it. So the stakeholders, it was an important task in this project to make a little bit noise about the tool. And this is why we organized a series of events in these different regions in the 6 countries. So we targeted farmers, landowners, investors, industries, all kinds of stakeholders that the tool would be interesting to them. And this helped a lot also in fine-tuning again and helping the people to perhaps implement their own projects. Also, of course, we had to talk with authorities, regional and local authorities, because this is also important in some countries. Even if everything is perfect, there are some political influence that is hindering the expansion of bioenergy. So on the other hand, as I told you previously, we have a help desk. This help desk is like the, let's say, the door where stakeholders could ask our experts in the project about any kind of question to help them if they want to implement a bioenergy project on MUC lands. So these experts goes from like really on different levels up to also financing and project bankability. Like the results we have also done, like we really wanted to go to up till the end in the real testing of these of the viability. So this is why we conducted some in-depth feasibility studies and business models to these 12 value chains that we already have tested. And as you can see, I don't know if this table, so we had different results. So in some countries or regions, some value chains were feasible and in some they weren't. And this is really important because we don't want also to say that this is a perfect thing, the MUC lands, anything can grow and everything is profitable. So we want to be really realistic, and the tool helped us really to decide whether we go for it, we don't go for it, where we could go for it, where we can't, and where this value chain is good, where it's not. So this in-depth feasibility studies also added value to this path. And finally, we wanted also to make sure that our tool is useful. And this is why we have involved an industry player like Neste, our partner in the Bioplat EU project. And they had the job or the task to conduct a pan-European assessment and to check where on these MUC lands some suitable oil crops could be grown and could be used for bioenergy production. Now the final results of this task is not yet finalized, but we have really promising results, and like Neste colleagues, they think that the tool is really a very good tool and it really helps a lot in taking decisions. And of course, for them, like we had in the morning a meeting with them, and they told us that they did find a lot of MUC lands which are suitable for oil crop production. And so this is a very positive from our side. So with this, I come to the end of my presentation. Thank you very much. And I give the floor, I think, to Manuela. Manuela from UNIOM Research. She will give you more details about how the mapping of the MUC land was done.
Thank you very much, Cosette, for the introduction. As it was said, that I will introduce the way of how we used Earth observations, so satellite data, to classify or to identify the marginal, underutilized and contaminated lands in Europe as the basis for the STAND tool. It was already also mentioned before that in order to reach the several of the European directives and also the SDG, for example, the target 7.2, which requests a substantial increase in the share of renewable energy in the global energy mix, all the renewable sectors have to contribute, and this is also bioenergy, of course. So on this side, but on the other side, as also was mentioned, the EU requests the sustainability issues to be taken into account. When we talk about sustainability issues, when we use land that's also used for food or feed production, it's always a bit of a competition or an issue, let's say. And that's why we focused in this project so much on these underutilized or contaminated lands, which can usually not be used for food or feed production per se because of this contamination or because it's not, it's just not usable due to several reasons. And so the first thing is how to identify these MOOC lands by remote sensing. And that's what our goal in this work package of the project. We attempted this, or we targeted to reach this goal on 2 levels. The first is a pan-European level. It covers the whole EU plus Ukraine, and this, with more rough data, let's say. And the second one is a level where we looked more into the detail, we used data with more spatial details, higher spatial resolution. And we selected the 12 case study areas, which have already, the countries have already been shown by Cosette. So we have 2 in Spain, we have 2 in Italy, 2 case study areas in Hungary, 2 in Romania, 2 in Ukraine, and 2 in Germany, as you can see from the map here. Now, when we talk about underutilized, contaminated lands, we need a definition. When is a land underutilized? And we use the definition, which is based on a definition from FAO, which covers all land which does not show any signs of human use for 5 years. In our case, when we started this analysis in 2019, this means that these areas, we could not identify any signs of human use through this satellite data, and I will show how this is done a bit later, from 2015 to 2014 to 2019. For the contaminated lands, you can imagine it's a bit more complicated because contamination is in the soil, so it's below the surface. And when we look from the satellite, from the space down, it's of course not so easy to look into the land and not possible to see the contamination. So we had to use existing data that's already there from in situ measurements on the ground, in the soil, and the related data that we could use and connect with national thresholds to identify these contaminated lands or areas of contamination. Okay, now I'll show you a very complicated graph, and don't worry, I will not go into detail. I just want to show that there are many steps connected to this assessment. And here we have the first part, which is the contaminated land, where we, as I said before, we use existing data, threshold it, do some post-processing on that. And we have a large part here, which is the underutilized land, where we use Sentinel data. That's a sensor from the European Copernicus Earth Observation Program. and also Landsat data, which is an American satellite, together with a lot of other information sources, and classify the areas which are not underutilized or which are not utilized, so underutilized, and then combine that also with some other maps, existing maps. For example, we cut out protected areas like Natura 2000, or we cut out areas which are very steep slopes, etc., etc. Okay, now we come, how do we really see, or how do we classify this underutilized land? This graph shows you now on the x-axis, you can see the time as it goes by. And on the y-axis, this is an index. This is something that you can imagine as the color from a photo that's taken from the satellite, so the reflectance. And over time, now each line represented here is 1 pixel on the ground, so 1 field, for example. And if we look now at the orange line, it's a cropland area. And when we see how the reflectance develops over time, we can see that here in winter, I hope you can see my mouse. In winter, it goes down. And then when the crops start to grow, it goes up, and then it's at some point in summer, it's cut and even plowed. Then it goes down again, and then sometimes there is a second crop, and then it's winter again, for example. For managed grassland in green, we see a similar pattern. So we have also a peak somewhere early in summer, then it's cut for hay, and then we have another peak. So that's typical a signature of a grassland. It doesn't go down so far. As you can imagine, a grassland that is cut still has some vegetation. So it's only shorter vegetation. While a crop which is plowed, there's only soil. So that's the difference in here. And now when we look at underutilized land, that's the blue line here, we can see that the pattern is different. Because an underutilized land means that it grows over the season, and then in autumn it starts to go down again. So there's no like sharp break in the time series, and that's what we are using in this project. These typical patterns which are different for used and underutilized. Okay, that was the ideal system. And now when we look in a pan-European application or pan-European assessment, underutilized lands look very, very different in the different areas. So it could be grass, it can be bushes, it can be mixed with stones, it can be needle-leafed bushes connected. So it can be a lot of different things that mix up these signals. So what did we have to do? We had, and this is reflected by this kind of curves. So we have a lot of chaos, let's say. So these are all underutilized areas, but in the different areas of Europe. So you can see there is a lot of mixture, and that's why we had to do it for each biogeographical region. So for each region which has similar climatic characteristics, we had to classify separately, and therefore we also needed reference data. And then we stratified by biogeographical region and classified each region with the respective reference data. Here you can see some results, and as you can see here, the overall accuracy is quite good in general. But of course, there are, especially in the Mediterranean and also in the Alpine areas, the values are a bit lower. And if you look at the patterns on the ground, like here, we are now in southern Italy. So these are olive groves, for example. And there are on the right, there are some abandoned areas, which are also partly covered with trees. And you can imagine that you have very, very similar signatures also in the time series. So of course, when we look in some specific areas, there might be some confusion, which is also reflected here in the results. Okay, now let's have a look at the map. As I said before, we've had two levels, so tier 1 and tier 2. The pan-European level, as I said before, is more on a rough scale. So we have a bigger minimum mapping unit. So we cannot look into every detail. We cannot identify every small batch, and that's represented by the striped areas here. And in pink, we can see the tier 2 level where we had more detailed data at hand. So we could also identify and detect also smaller patches, for example. And this is quite nicely shown here, that the small patches and some other patches are found with the tier 2. But in general, we have a good agreement, so we're mapping the same thing over here. And this is just another example in Hungary, where we see in two different areas how this identification of MOOC lands work and how the areas look like that can be then used in the follow-up stand tool in the WebGIS system. Now this is the whole map of Europe, and I want to also say some considerations with this map. The first is, as I said before, that with this map we have covered the 2015 or 2014 actually to 2019 period. So that means, of course, these areas can change year by year. Sometimes they are left to fallow for 5-6 years, and then they are for some reason recultivated. So that's something that has to be taken into account, of course. As I said before, in some small structured agriculture, we have this 30 by 30 meter pixels, so this could be an issue sometimes. And what also comes quite often is that we have very large areas of contaminated lands, which we can see here in blue on the map. And of course, this is something that that comes from the existing data set. So we cannot, we can only take what is there, and it has to be, it's important that, of course, for the realization for the project to be built in, it's needed to check also on the ground. What we have built in is also, if we identify some areas or some aggregated lands, as was shown also by our colleagues from Neste, that if you find a cluster of MOOC lands, it can still be expanded and then used in the tool to see also how the numbers increase if you have more land available, for example. Then what we also provided, and I think it will still be mentioned also in the next presentation, is that we have collected geospatial data on the biomass processing plants. We've collected almost 3,500 of those, which are then used also in the WebGIS system in order to connect the plots, the MOOC lands, with the respective biomass processing plants nearby. And what is also nice, I think it will also be shown later on in live, that you can also add your additional plant. So if the plant is to be built or something is going on, then this is a possibility. Okay, so with this, I hope I could give you a glimpse on at least on our work we have been done using Earth observation data, remote sensing data, satellite-based data for the identification of the underutilized lands. If you need more information, I've put some of our publications which have been done in the frame of this project. And also I want to mention that all the data is publicly freely available through this Zenodo link. So you can find all the data there, and they are free to use with, yeah. Yeah, and oh, thank you. And we won also a Best Paper Award for this on the ISD, the International Symposium on Digital Earth. this year. So it's also nice. Okay, then that's it from my side. If you have any question, please don't hesitate to ask, or otherwise I will give back the floor.
Yeah, many thanks, Manuela. Excellent. Other than in most other workshops, we are ahead of the schedule. I think we should take advantage of this situation, and I would propose that we continue now with the presentation by Lorenzo and Alfonso, and then basically we could use some time for direct questions, maybe from the audience, as if we still then have enough time after your presentation. So Lorenzo,
yeah,
it's your turn. Yep.
Okay, can you see my screen?
Yes.
Okay, thank you. Maybe I can start giving a short introduction of myself. My name is Lorenzo Traverso, and I'm a consultant with the FAO. And since 2016, I have been working with the Global Bioenergy Partnership, before with the FORBIO project, and now with the Bioplat EU project, focusing on the sustainability of the bioenergy production, and of course in the development of the tool to assess the sustainability of the value chain. I like to start with one question, and I know we went through this today many times, but let me stress these points once again. First, there was a real need to have a better characterization of those underutilized, marginal, and contaminated lands. And then, why Bioplat EU? Also because there was the need, and we took the opportunity to create a common space, a shared space where researchers, where investors and farmers can actually better investigate about this marginal, underutilized and contaminated lands, and then of course to the sustainability component. So we took the chance to develop a new sustainability component and to add that to the recipe. And if we follow the recipe, then when we get to what we have done, so to the tool, to the WebGIS tool, that is a decision tool, as we said before, which answers too many questions. Where are those lands? How much land I have, and is it available? And then, may I have sustainable production on those lands? Not only profitable, but also sustainable production. And here we have a picture with the structure of the rough structure of the Bioplat EU platform, that it's made in two main components, because that was presented before. One is the website, and the other one is the WebGIS tool. In the website, you can find general but also technical information, such as news and events, but also technical deliverable information on the project, on the partners, and guidelines, the manual for the WebGIS tool. Sorry, and then we have the help desk that where users can address questions, and where you have experts from the different partners. Now we go to the second component, that is the WebGIS tool, that is in its turn composed of two different subcomponents. One are the maps, and as we have seen now with Manuela, the long approach and all the work that has been done to have those maps and to get to that very good characterization of Europe. And then we have the Stan engine, that is the tool for the sustainability assessment, that is based on the GBEP methodology, the GBEP sustainability indicators, and the previous adaptation for the FORBIO project. Let's go through the tool, and these are the indicators for those of you who are already experts on GBEP indicators, who knows the indicators. You can see two different changes here. One is that we have a reduced number of indicators, and the other one is that we have this differentiation between the core or standard and advanced indicators. Yeah, for the reduced number, we have two main reasons. The first one is that some of the sustainability GBEP indicators from the original set of indicators apply to developing countries. And so we couldn't insert those indicators in our analysis, in our tool that works in Europe. And then also there are indicators in the set that are too specific. For example, soil quality or water quality. Since we are working with this tool in an automatic way and we are considering the whole Europe, it was not possible for us to add these indicators. So that's why we have less indicators. And now let's see why we have these differences between the standard ones and the advanced one. This is mainly because we have two levels of analysis and two typology of users. We have standard users, and then we have advanced users who have to log in with their credential. And of course, the first difference is that a standard user can measure standards indicator, and an advanced user can measure two additional indicators, the advanced one. But this is not the only difference. The main point is that in the process, this is, let's say, the flow, how the information goes through the tool. In the first steps for both the advanced and standard, you have to decide the place, you have to choose one crop, you have to select information of the agricultural and agronomic input in terms of management that you give to the crop. Then you have to choose a pathway, so the type of bioenergy product that you are going to produce with those crops. And if you are a standard user, you only provide this information. And then thanks to all the information on the area, on the climate, but provided from the database, in an automatic way, you get to the results. The advanced users, of course, they have to type this information, but then after receiving the information from the tool, so from the database and the layers, they can modify this information. So they can go deep into the tool and change the numbers to get to results that are more accurate and that are more realistic. For example, if I'm a farmer and I know that in the place I selected where I'm trying to have an idea of a possible investment, I have a yield for the maize of 7 tons, but the tool is saying that it's proponing a yield of 10 tons, then I can go there, I can change the number and have a yield of 7 tons per hectare, and of course get to a result that it's more realistic and useful. Speaking of yields, maybe you're asking, okay, if you're a farmer, you know what is the yield in your field, but how the tool can know the yield of or the suitability of a crop. And that's why I put this image. We know it from the GAES, that stands for the Global Agroecological Zoning. It's a project, it's a tool from FAO, and thanks to them, thanks to this tool, we were able to have a list of GIS maps for suitability, crop suitability, and for productivity, means the yield in tons per hectare, of a high number of crops that you can see on the left part of this table. So on the left part are all the crops for which we could use the information from the GAES tool. And unfortunately, from the right side, we have the crop for which it wasn't, I mean, they're not covered by the GAES, and so we couldn't find maps and information from the GAES, but of course we have them into the tool, into the analysis, because we was able to find maps, information, layers from JRC and other secondary literature. Here I have a picture. It's the main interface of the platform, of the tool when you open it. But we will have Marco Colangeli, my colleagues, running a live test. So I don't think I have to go through this, but we will have time later to go through the tool and try to test it. Again, here on the left side, and now this time with Alfonso and our colleagues from Spain, we will see these components, but these are the ID systems that has been translated starting from the methodology. So on the left side, you have the flow. Then in the center, we have a screenshot of the tool. On the right side, as Manuela was saying, we see a distance from a biomass plant and the potential site. So after the user has identified the site, chose a crop, and decide the value chain, automatically the tool has selected the nearest place where the bioenergy product can be processed. But we will see this during the live presentation. And then, of course, we get to the results. The results are listed, divided by standard indicators and advanced indicators. Of course, both environmental, social, and economic one. And now you can download a PDF format with all the results and also the numbers of the characterization, the data of the characterization of the area, of the land, to have a comprehensive picture of the value chain. But we are working also to have a new option also to download this information in Excel files. And that's it from my side. I don't know whether we have question now or we want to keep this question for after the live test. Anyway, now Alfonso or David can give us more information on how these methodologies has been translated to the ITE system. Thank you.
Okay. Yeah, thank you very much, Lorenzo. So I understand, Alfonso, you will give us some more insights on how this all came along. Yeah, so I look forward to that. Thank you.
Okay, but okay, only to say that in this presentation of the the WebGIS tool, the speech will be realized by David Cifuente, that is the computing engineering in charge of the implementing and the development of the tool, and then probably we will go in deep to this tool. Please, David, go ahead.
Thank you, Alfonso. Good afternoon. I'm happy to see you again, colleagues. And I am engineer of information technology at the group of the remote sensing at the University of Castilla-La Mancha. And I'm going to try to explain all the words or the most important parts of the web basic platform about MOOC lamps. Okay. The WebGIS tool is the integration of both the GIS maps and the STEM tools and link it to the project website. It is the public platform which as a hub for information, methodologies, and tools for bioenergy sustainability to support development and deployment of renewable energy. And the user can simulate the potential to produce biomass for not food purpose for sustainable bioenergy on MOOC lands. For the construction of the tool, the procedure for taking functional requirement has been the constant interaction between the members of the technical teams of the projects, constant exchange between FAO, GR, and our own university of USLM, hold technical meetings and webinar and specific tasks. The construction was planned in 3 deliverable phases: a conceptual design for taking user requirements. It was finalized in the month 6. A prototype to evaluate the feasibility, the defined user workflow, and the demo with the subset of data for some indicators. It was finalized in the month around 24. And the currently web system is the operational WebGIS with all the functionality and layers to run the STEM model. All the technical details of the WebGIS construction can be found on these deliverables, deliverable 3.4, 3.5, and 3.6. This is the overview about the WebGIS architecture. Regarding the system architecture, is based on client server, where the information is accessible by web services. On the front end or the part of the interface have two parts: a public interface with a map viewer, where the user interacts with the platform, and a private interface to administrative tasks for managing metadata, layers information, and enable user and other options. The interface has been developed in Angular and Open Layers, has been used as a core of the map viewer. Is the public part. It has been carried out a great effort to technical and format for representation in huge volumes of vector features on the map viewer. At the backend part or part of the server is developed in different technologies and frameworks like Node and additional to Python for script to access spatial data using GDAL. And for the database, we use MongoDB, and Specialized has been used. And the backend is made up of three main blocks: the set of the web services destined to manage management services, map services, and interaction with stream data. The modules in charge of the logic are map server, spatial leaf, and stream engine that allow to the access the spatial data, raster image, and calculate the stream indicator. In the data handling block, data model architecture has been designed in two levels. The first level in charge in general data and stream data, and the second level handles spatial data schemas. Is contained the vector layers and raster image. The basic layers of the project are the cross-suitability and raster layers. This is the KF layer. The vector layer of MOOC and biomass processing plants. This is all the information that I had in the project. And the layer of management, the administrative limits. The more significant layer are the target area-based layer. This is the municipal level, and contain statistic information and social and economic data that used in the STEM. The main functional requirements are summarized in this table. All the requirement defined in the conceptual design has been developed, as well as another requirement that, for example, Marco has commented in the last presentation. The most interesting requirements of the WebGIS are the interface is adaptive at the screen, the platform alone, the registration of user. There are two user roles, advanced and standard users. Standard users can perform all the basic actions and consulting information without registration of the platform, even generate a report and download it. To be an advanced user, a login is required, and it can customize all the input data according to their own user and knowledge. It can define mega MOOC by aggregating several MOOCs. The system supports multi-language with aspect of translation and formats according to the language. Regarding to the functionality related with the maps and the sustainability tools, the system has the accessing and downloading to the basic layer graphical and numerical information about the basic layer about MOOCs, base layer, excuse me, information about OpenStreetMap or layer infrastructure. And the main requirement of the application is the computing online of the environmental, social, and techno-economic indicator, is the STEM, the calculation of the indicator run online on demand. And another aspect is that all the information is downloaded to the STEM reports, and the system about no functionality requirement is that the infrastructure is scalable and reliable. In addition, the response time of the simulation are in seconds. This is the table where you can see the difference about different roles. No? Have to user role for integration with the platform. The standard user has access to visualize all the layers, consulting spatial information, and calculate the core indicator. And advanced user require registration, inherit the characteristic of the standard user, in addition to be able to edit values of the value chain database, edit custom crops, and define the biomass processing site based on the selection of multiplex MUs, as well as the calculation of the advanced indicator. This is the input data flow, represents how the spatial data input is combined with the STEM input data. This interaction is key on the wedges. In a few steps and with a minimal user information, the platform can calculate near automatic way the value chain database. The first step is to select the MOOC. This can be visualized from the map or through to the search engine of locations similar to Google Maps. By default, the full MOOC area is considered the biomass production site. This area can be defined by hand on the map, and advanced user can select multiple MOOCs in the BPS defined. The next step is define of agronomical information. For this is required the management of crops, water supply, and crop name. And the wedges automatically calculates on fly the suitability, yield, and the biomass production site. The next step is important is define the bioenergy pathway suitability for the crops, and the calculation of biomass transport will depend on the selection bioenergy pathway. Marco in the presentation is explaining more detail this aspect, the distance and the agronomical information. This input parameter allowed to the platform calculate the value chain database in this area, and the value chain is the input data to STEM. This is the first step that the user is the minimal information that the system needs. Automatically extract all those information in the system about the layers and the information relation with the database, and give the value chain database. The data structure and information are crucial to operation in the automatic way. The model is operating without manually supply data by the user. Also, a user can customize input data in a flexible way. And the last step is the output of the results of environment, social, and techno-economical indicator analyzed according to the STEM model developed by FAO. This is the workflow with more details about agronomical information and bioenergy pathway list. Currently, there are these crops and this kind of bioenergy pathways, and the choice of the crops determines the bioenergy pathway compatible with the crop and the algorithms for the transfer of biomass until its treatment. One key point of the project has been the construction of the STEM engine from the STEM tool in Excel. The STEM tool model is complex and developed in Excel, but it doesn't have the spatial data. The STEM engine construction reproduces the model calculation in STEM, STEM remotely and integrated layers about nuclear suitability layers. Therefore, the GramMath language has been designed and implemented to translate the Spring set calculation into a computing language able to support via web accessing. The engine does a lexical, syntactic, and semantic analysis of the STEM formulas. Is allowed to is more extremely flexible to change and easy to add new indicators. Working each indicator as a set of variables where the engine calculates the operation between variables. This allows in a simple way to incorporate new change and new indicators without modifying the core of the engine. Only is necessary to modify the variables defined on the file. The special information is retrieved by the web services and prepared to introduce in the STEM model. The wedges perform different operations in the user-friendly way in recovering data from layers of information. Data used in the value chain data bus and in representation of elements in the map. One of the most outstanding operations in the algebraic operation between raster vector layer that is carried out on the backend. The wedges calculate on fly the yield and the percentage of suitability of the select crop in the area for the guide for skating model. The freedom of the drawing the BPS by hand doesn't allow having pre-calculate data on yield and suitability cross associated with nodes. For the calculation, an algebraic raster vector operation is performed with the BPS geometry, the results of which is applied a tonal statistic for each of the cross suitability and yield map from guide layer produced by FAO. The response of this list of the agronomical information on crop is those suitability is greater than 30%. This is the most important operation maybe in the system and is doing on fly. No? We have more details on the deliverables about this operation if you are interested. And belong to the project, user element will be in charge to maintain the tool for 3 years after the project. The system is prepared to easy to update the layers and data model. We have this compromise in the project, and I think that all the data, all the jobs we have, we open the new lines to do in the tool, in the wedges tool, to create new tools, new lines to invest or even another project. No? Thank you for your attention.
Yeah, many thanks, David, for this very interesting presentation. It certainly shows that quite a lot of expertise and hard work went into developing the tool. And now so many thanks to all our speakers who now presented an overview basically on the main results of the project. And now actually Michaela and myself, we would be moderating your questions in case you have. So Michaela, what do you think? Should we wait for 1 or 2 more minutes, and then if there are no questions, we will just have the break a little earlier?
Thank you very much. Thank you, Rainer. Well, I would say I have invited participants to start inserting their questions in the Q&A box, or if they prefer to intervene by taking the floor and through the system directly, they could raise their hand. I don't see any for the time being, so I would say we are a little bit in advance, but maybe we could slightly anticipate the presentation by Marco, if you agree, and if Marco is fine with this, because then we could have a half an hour break, and then in that time, maybe participants, they could think a little bit more twice about their doubts and questions, and then we could reconvene after the coffee break for question and answer. What do you think, Rainer?
Yeah, okay. No, if everybody promises to come back after the coffee break, not only that, you know, that I'm fine with that. No, I think Marco, the floor is yours. Give us a good show. I look forward.
Thank you, Rainer. Thank you, Michela. I think that few questions are starting to get into the Q&A, but maybe since we made this decision, I might go over the quick demonstration, and then perhaps based on that, further questions will arise. And like you said, there will be also time for other participants to pick and decide to asking more questions. So I will share my screen, and basically my screen will simply be going on the website, as you probably have seen already before. This is our project's website. It's bioplateau.eu address. Like other colleagues have presented, there are the main features. If we click on the WebJS tool, we are prompted to a dedicated page as a structure of the platform. And by clicking on this, we open a new tab with a quick disclaimer that will come and tell us what is the real purpose for Bioplat EU. So the first thing we can see here is onto the left-hand side of our screen is a selection of different layers. Those of you who are familiar with GIS systems and the likes will probably recognize the opportunity to superimpose different layers by selecting them, let's say, individually. Now, when we select a first layer, the layer on the underutilized lands or the contaminated lands, another disclaimer comes up because, like we said, and like Manuela kindly presented, the science behind the production of these lands, which are our reference system, is very well expressed in the work done by the Joanneum Institute. And so we will warmly suggest you go and review the detailed reports, which are also linked in this disclaimer itself. So like I said, why do we have a layer system where we can turn on and off different layers? This is intended to give maximum versatility to the users. So a user can actually decide what's their entry point. For instance, if you are, as a user, a farmer, perhaps knowing whether your land is underutilized or contaminated land, or basically whether over your land you could start a biomass production for bioenergy purposes. So this is one entry point. A different entry point might be that of a bioenergy producing company, which instead may be interested in knowing where is the closest land where biomass can be produced as a feedstock to their existing processing plant, or a mix of the two. It could also be for research purposes that none of these are really relevant, but the opportunity of giving users various entry points, it's certainly interesting. So now let's pretend we are, or another important thing is, let's say that we want to know what is an area that is suitable based on the suitability of a crop that I, as a user, might be interested in exploring. And like we said, we have the opportunity to select different crop suitability coming from the various databases like the GAIS, the Global Agroecological Zoning, as well as the JRC maps and others, depending upon the crop. So if we look at also these maps, another important aspect is that on this interface, we can pre-select different filter options. For instance, the type of a specific type of bioenergy processing plant, because we have mapped them by bioenergy processing, let's say bioenergy pathway. So we can either only have at screen those plants that already produced heat and power from solid biomass, for instance. So here we go, we have the black dots, or we can have all of them in the same picture, or we could also decide to hide this layer altogether. So once we've decided our area, for instance, we can now start moving towards maybe an area where we see there is a higher density of underutilized lands, according to the mapping exercise that we have done. And this is how the system allows us to start this analysis. For instance, let's say that we have a patch of land that is in this area right here, near this town, and we want to start selecting a reference point, which is the specific MOOC land. By selecting it, the system zooms in and it opens up the STEN engine, as you probably have seen. So now with the STEN engine, we have the opportunity to characterize better and further define the value chain that we are looking at. So now the first thing we notice is a few basic information about the size of this patch. And then we can start working either within the patch or adding multiple additional MUC patches. So if we want to start looking into this in particular, we have to open up the little toolbox that is associated with each MUC patch. And within this tool, we can, for instance, draw a field that is inside a specific patch, save it, and now the system only considers this small field, which in this case is only 13 hectares. And in case this selection is correct, then we can move on to further characterization of this little value chain, or perhaps we can step back and instead clean up this and restart our analysis. In case instead we want to add additional MUC patches in the same area or in a different area, we can tell the system to do so by allowing us to select an additional one, include it, and now as you can see, these two are summed together. So if we look at the total surface area interested, we can add even another one, this one for instance, select it, and the total is a sum of the surfaces of all of these areas. Now, once we have selected the reference biomass production sites, or in this case sites, we can start defining through agronomic information what are the main characteristics of the value chain. Clearly, the crop management system that we can select will affect both suitability and expected yields. But we should then keep into account that by signing in, we will have then the opportunity to change all of the characterizing and defining parameters for the crop management, as well as the location and let's say the development of the value chain itself. So the options that we can select are between low and high input level, which includes tillage, inputs in terms of fertilizers use, pesticides use, and so forth. And then we can select among a drop-down list of crops, which are already those that the guys and the other database that we have selected tell us are suitable in this area. Or, like Lorenzo said before, a specific user might be interested in testing a different crop that based on the suitability layers that we have already collected is not included. So in this case, there will be also the opportunity to select a slow tool, select from the complete list of crops. For instance, we can select a crop that was not included in the previous menu, and also we can characterize a given yield at this point, because our yields are based on available maps from GUIS and, like I said, JRC maps. But if we are forcing the system to assume that there is the opportunity to grow also a different crop, then we will have to include a given yield based on our experience. This is yield and dry matter per year per hectare. So it's, let's say, simple number just for ease of reference. As you can see now, the system shows us with the yellow underlining that there are parameters that we have changed, and we have told the system to use our reference parameters. And obviously, based on those data that we have inserted, the system already calculates the total feedstock production per year. Why is this useful? This is useful, first of all, to have an understanding of what we're talking about, but in the user case of a biomass processing plant owner, the owner may need to know what is the minimum amount of land for that specific crop to produce enough biomass for their own use. And then we can select the bioenergy pathway by simply selecting one of those available. Once the selection is accomplished, the system automatically selects the nearest bioenergy producing plant or processing plant from the list that we have already included in our system. But in case we want to force again this by because we know the existence of a biomass production plant that is closer to that one, or if we want to assume what if we build a new plant here in this location, again, we have the opportunity to tell the system to please look for the closest route to this area from the center of gravity of our biomass production site, and the system will calculate that automatically for us. Once we are happy with the selection, we accept the selection, and the system takes us to the first important aspect, which is the value chain data box. In this part of the tool, we can review a few basic information of the target area, which is the reference area interested by the municipalities that are involved in this production cycle. And so we can see information and statistics about the composition in terms of land use or land cover in this area. And then we can also go down to a more specific crop information. Again, you will find here information on the yield, which are circled in yellow because we inserted that. We can again change this value in case we made a mistake or we realize that we need for a specific purpose to amend this. But then we can also change other parameters, like for instance the evapotranspiration of this specific crop that we have selected. This information is by default what we could find in the literature, but a specific project might have more updated information and therefore change that, and so forth. We can go on market price and additional agronomic information like the amount of fertilizers per year and so forth. Once we're happy with this, if we are a advanced user, we can also look for those indicators that we have already identified as advanced indicators, those for which data it's not available as default, but we need to include information to actually compile this analysis. Otherwise, the analysis will not be profitable, will not be fruitful. Sorry. So we can now simulate, and in a matter of a second, the indicators, standard and advanced indicators, are presented at screen. So we can now review this, we can download the information, and then we can compare the different simulations down the road. So this is one user case. I invite everyone to go back on the website, the Bioplat EU website, select the STEM tool, well, select the WebGIS tool, and then experience yourself what is available and what are the, let's say, the potentialities, what is the potential of this tool and of this platform. So I leave it here. I hope this was comprehensive enough. If you have any questions, I'll be happy to read them and then to give you answers. So thank you very much. I will stop sharing my screen right now and happy to take questions right now, or if Rainer and Michela prefers, we can take them after the break. Thank you.
So Michela, what do we prefer?
Well, we could give a first round of comments, because I saw that there were a few questions from our colleague Anna Kojakovic, but then as soon as Marco went ahead with the presentation, they were replied, and therefore they are considered as replied, unless there are other remaining questions from Anna's side, or let's have a first round of additional questions from around the table. If there are other colleagues amongst the participants that would like to raise questions, let's see. I see the reply from Anna. Thank you so much. Well, I have a question actually that I, to start warming up the discussion. In the context of an international initiative with whom the Global Energy Partnership is collaborating, which is the BioFuture platform. In the context of the BioFuture platform, which is an international initiative which is mostly focused on bioeconomy products, that of course includes also bioenergy. There is now a so-called BioFuture campaign, which implies action from private sector in order to mobilize interest and cooperation among the private sector companies on bioenergy, bioeconomy, and sustainability. I will finish my question, then I see that you see the chats have started being populated. So in that context, I believe that this WebGIS tool could be extremely relevant. Of course, it's wider in terms of objective, because it's not only bioenergy, but already bioenergy could be a good starting point. But of course, it could be applied, or the interest would be to have it applied to other regional areas. So my question is, of course, the objective of this project is and was to develop this tool for the European region. But my question is, in order to widen the cooperation and the support that this WebGIS tool could give beyond the European context, what this would imply, what this implies in terms of additional projects, real projects, to be developed in additional regional areas. And before they start replying, maybe we could also ask Annalisa Zezza to take the floor. Ciao, Annalisa. Good to see you. Please unmute your microphone. Annalisa, can you hear us? I'm not sure if Lorenzo could unmute.
Actually,
here we are.
Hello.
Yes, now we can hear you. Ciao, Annalisa.
Yeah, I think it was a mistake. I didn't raise my hand, but I take the chance just to say hello to everybody and congratulate for these very interesting results that I think are full of potentiality for the European Union in the context of the new Green Deal and of the bioeconomy. So I just want to congratulate, and sorry for taking the floor, but really, I don't know how it came that I had raised my hand, but
no problem.
Again, but it was very nice to see you back, and I'm looking forward to meet again the whole GPF family, hopefully in person.
Thank you so much. It has been a great opportunity also to say hello in online, Annalisa.
Yeah, also from my side, no problem at all. It's interesting to hear some other voices also. Michaela, thank you for your question. I believe, especially in the framework of the GBEP, that sounds a very interesting question. No? Of course, based on the lessons learned in the Bioplat EU, it would be a new initiative. But I think what would be maybe interesting to discuss here also with the experts like Manuela and David Alfonso, is whether they believe that also in other areas of the world, the data would be available, kind of, or would it be available? I assume, Manuela, the the GIS, they fly everywhere, no? Like the satellites, you would have the data probably, no? Yeah.
Should I try again?
You have to come here.
We have to do it this way again. Sorry.
Sorry, yeah.
I don't know why my computer does it.
Because it's only here that gives the voice. So.
I see. Yeah, of course. I mean, the satellites are not the problem. So as you pointed out correctly, the satellites fly on every point on Earth. So we can map every area in the same way, basically. So that's not a problem. There are only some statistical issues which are at the moment used in Europe for these social and economic assessments, where we go back on Eurostat, and that might be a bit harder to find in other areas. But I'm pretty sure that we can also find information sources, maybe on a more aggregated level or whatever, to build or to copy some system in any other parts of the world. So I don't see a big barrier here.
Manuela, maybe also the underutilized lands would have different baselines, you call them, I think, maybe reference levels.
Yeah, that's true, of course. I mean, you cannot use reference data from Europe and transfer it to Africa. You always have to adapt to the situation there. You have to make the system learn how underutilized land looks like there, and then you can classify. But in principle, the data is there. So it's just a matter of effort to collect these data sets and then to classify again. But it's basically possible.
Maybe to follow the answer, that first in the case of technology, I think the different layers, the most important thing is the tool is ready to work in the global area. But the most important thing is what you put into the tool. And then probably the question need to be translated, need to be answered by Lorenzo and Marco about the if we do have the layers, the suitability layer, the crop suitability layers for all parts of the world or for different parts of the world. Probably this is the right question to be answered. Is this the information, the base information that has been uploaded into the system is available in other parts of the world beyond of the European limits? Lorenzo?
That's the 1,000 millions question, but yes, I agree. And I think that maybe we should proceed step by step and to finalize the tool now for Europe, and maybe to understand whether we can have more detail, more information, and to get to a final tool only for Europe and maybe the neighboring countries, more neighboring countries with more data, more maps, more, for example, bioenergy plants, and instead of moving to the whole world and trying to create a second tool, a new tool, bigger, but with the same level. It's just an idea.
But then Lorenzo, actually we had a project meeting earlier today, but we didn't find time to discuss next steps in necessary detail. But so how much work, like, obviously researchers and Lorenzo is finishing his PhD, yeah, they always want to continue work, yeah, I can understand, yeah, no, but at some point you need to you need to apply, yeah. When do you think, you know, it doesn't need to be ready, but I think it's good enough now, yeah? What do you believe?
No, I think it's good enough. I was answering to Alfonso. So in the future, it's possible to have an updated tool covering more areas, but maybe we don't have to go and get globally. We can focus on Europe.
No, but this is what I was questioning. You know, why are you 100% sure we cannot say it's not that we are doing it, you know, but I think it would be possible to extend the Bioplat approach globally, even with the knowledge that is around now. This is correct, no?
Yeah.
With new projects, we are not talking about applying and replicating the tool in different areas within this project. Of course, we are at the end of the project, but it's a good, I mean, it's a good thinking of starting anticipating the next step and draw the lesson of the Bioplat EU project and replicate these same tool in other additional areas. And these application in other areas, of course, could bring some challenges in terms of data availability, of course, depending on the area, or not, depending on the area. But it's good to start thinking that the WebGIS tool is giving us a good instrument that could be replicated also elsewhere, but implying anyway a huge amount of work to replicate it in another area, of course.
I would like to highlight one thing, but that is the legacy of the project in my point of view. This type of WebGIS tool has a particular jump on the process of accumulate knowledge, because we accumulate knowledge, but the knowledge accumulated is into the tool and available for all people interested on this type of tool. And then it will increase. If we improve the quality of data we upload onto the system will provide better results. And then this is a process that feed the tool, and then is increasing the accuracy, is increasing the data we receive. And then this is a process that we can produce several steps, each step increasing the global knowledge. But no, it's not a knowledge in the hands of a few people. It's a knowledge in the hands of a lot of people. This is the change with this type of tool, when the tools are open to the rest of people, not only experts. Because the problem of we have a very precise model in the research environment. This is only in the hands of very few people, very few experts. But the change is to put this knowledge into the hands of a lot of people. This is probably in the social science is not well considered, this type of increasing of knowledge we obtain. Okay, this is probably beyond of this, but this is the typical things. But it requires to maintain the tool and to increase the tool use, because the tool grows mainly by when the users utilize the tool. This is the combination of both things. Okay, this is a reflection beyond of the project, but I think it's possible to do that according to our experience, according to the other tools. But in this case, for me, has been this process. I have seen this process. Okay, thank you.
Yeah, thanks, Alfonso, for highlighting this. Now, it was mentioned before that the tool will be available for at least 3 years, open to all users, as you were just describing. But then, of course, we do hope that also other projects might follow up for further refinement of the tool. Michaela, to come back to your initiative of maybe extending this approach. How high is the MOOC Lens on the agenda of GBEP? Sorry, I didn't have the possibility to follow this topic. You know, so is it very much discussed in southern?
Well, not as much as in the European context. At least not in areas like Africa or maybe Asia. For example, in the case of the Americas, there could be some interest. we do not have an activity group specifically focused on marginal, underutilized, contaminated lands, no. But in the past, BBEP has been focusing on biomass quantification in the past, and the BioFuture platform is now focusing on biomass quantification. And therefore, you see that there could be a synergy between the available tools, between the interests, and therefore there could be an interest in the near future to discuss cooperation or a further application of this tool in other contexts. Food for thought.
Thank you. No, and I think all over the world there is the issue of what to do with the such lands. So in some cases, maybe leaving them alone is a good opportunity, but also with respect to the remediation topic, especially in some dry areas, you know, that could link into other very interesting initiatives, how to sort of recultivate land, you know, what to do to remediate and reclaimate such kind of land. I see that things are happening in the question and answers, but our colleagues are so fast to answer the questions that we can take none to the podium. So thank you very, very much, Marco and Manuela.
I would like, Rainer, I would like to ask Marco. Marco explained perfectly the tool. Marco did a perfect overview of the tool, showing the tool, and then this is a combination, because from the beginning of the project, it's clear that the tool is not only a task for computing engineering, it's a combination, and then probably the tool is the combined work of Manuela, Karina, Marco, Lorenzo, and a lot of people that put the knowledge into the way that the tool works. And then it is clear for me. This is intellectual property for this type of things. It's not linked to the computing, the technological part. It requires culture, requires knowledge, and then both things are inside of the tool. Then Marco, please, I would like to ask if you are comfortable when you explain the tool, being the designer of the tool. What do you like?
Thank you, Alfonso. Yes, if I can call myself the mastermind behind the tool, it would be nice. But like you said, it's been definitely a teamwork. And this team, actually, if there is one thing that I realized at the very beginning of our activity, and that if we go further for a new version, let's say version 2.0 of this tool with the different projects, I would definitely include in the, let's say, forecasted activities, the opportunity to meet with the technical team, as we did, but include and dedicate more time and resources to that, because this bouncing back and forth of ideas between what is available in terms of data, and this information would used to come predominantly from Manuela and Karina from the JR Institute, what it's needed to really express and define sustainability, and this would come from Lorenzo and myself from FAO side, and what is achievable and doable with translating that into an actual working tool, that it's user-friendly, it's not too cumbersome, it's something that can really make a difference to decision-making tool, was coming from the colleagues at UCLM. And therefore, I think that this is something that really represented a strong and very fruitful collaboration. I believe that now we set the basis. I've also said this in the previous session this morning. We set the basis and we realized basically the chassis and an engine of an architecture that can be further developed and applicable to many different scenarios. I believe that, in fact, as it is today, it could be already taken as a stepping stone for assessing a number of interesting sustainability parameters linked to bioenergy worldwide. If we had the time and resources to, obviously beef up the engine and the databases. And I'm actually very much looking forward to do that. It would be really interesting to see if any one of the participants have any idea or specific need for us to, see if there is opportunity to apply this worldwide or to other regions. So thank you very much, everyone, for this collaboration. I really enjoyed it myself, and I think we did a very good job.
I would like to. This is the answer I have. Okay, thank you. You are muted.
Yeah, sorry. Many thanks, much appreciated. Marco, while we were talking, it came to my mind, could we maybe use your intervention as a tutorial, how to use the Sten tool for the website? Or maybe you could even record a new one. It just came to my mind. It's nothing for the workshop.
Absolutely.
But could be quite interesting. Yeah. So just a few minutes. Maybe we can even take the one recorded from this call. So Michaela, what do you think? Should we take a break for half an hour until 3:20? Some more questions might come up, and would that be fine?
Absolutely, yes.
You're ready for a coffee. So many thanks again to all speakers, also to the questions, and yeah, a few of them could be answered, and try to come up with new ones, and then after the break we will discuss about maybe some more details on synergies with VBEP, or even how to move forward with the tool or anything else. Thank you.
Thank you so much. So we will reconvene in half an hour, right?
Half an hour, 3:20.
Great.
Thank you.
Thank you.
Rainer, I see colleagues are back in the meeting room. We have the advantage and the privilege to see you all seated. It's a pain for not being there with you. Believe us.
Yeah. Also, the cookies were very nice, Michaela.
I can imagine. You are putting the finger into the pain.
Yes, so colleagues, welcome back. So I believe we continue with the questions and answers, and then yeah, try to have some discussion on interesting topics. And then Michaela, is that a presentation you will give on the synergies, or?
It's more some considerations.
Okay. So good. Okay. So actually, Alexandra, are you available? So actually, we have mobilized a question here from the audience. I will again move and give the floor to Alexandra.
Yes. Hello. My question is to Lorenzo and Marco, and it is about the air quality indicator and the comparison with fossil fuels. So the question is that when we compare the bioenergy value chain with the fossil fuel alternative, we now see the comparison with the petroleum. And so my idea is that in case of transport fuels, maybe it is very convenient and useful, but what if we consider CHP, for example, where we can have an alternative with natural gas or coal as a fossil fuel alternative of such a bioenergy pathway? So are these factors, CO2 emission factors, considered maybe, or maybe they are in progress? This is the question.
Thank you.
Oh, am I muted?
Thank you for the question. Maybe I can start. I don't know whether Marco has more detailed information. The comparison with the fossil fuel, the petrol, it's the official way, the European way. We have also in the RED and RED 2 this type of comparison. assessing the differences. Well, it's a good point to have a differentiation between the old pathways, and again, this means additional work. And for example, for electricity, a good idea could be to have the emission factor, the national emission factor for all the countries, and then to compare the emissions of the proposed value chain. Marco, do you have any additional comments on this?
Yeah, thank you, Lorenzo. Thank you, Alexandra, for your question. I mean, you're right. For different bioenergy products, there is different reference fossil fuel or, let's say, traditional alternative. And in fact, this is something that we also have included in the, let's say, more cosmetic type of additions rather than a key function to be implemented. So if it's possible, we will have the selection of, so basically, because what we need to link now is results of the testing, or basically bioenergy pathway selected, linked to its reference traditional alternative, which would be petrol for liquid fuels, as Lorenzo said, for according to the RED, for instance, but it would be natural gas, or actually it would be standard electricity grid of country national grid system for power, so for electricity produced. And so we will need to find a way to link bioenergy pathway with a differentiating reference traditional fuel. Yes.
I don't know if you found the replies satisfactory, or if there was something additional that you wanted to ask.
No, it's okay.
Fine.
So, okay.
Please go ahead.
So is it planned to be integrated, or for this time it is not? No, okay. Thank you.
Yeah. Also. Astag just sent some information that there is different comparators for different use of fuels. You can also have a look at the comment.
Right, yeah, Asta's comment is along the lines of what I anticipated. So for different bioenergy products have different competitors according to the RED, and we are trying to also include those. But the thing is that we will need to discuss with Alfonso and David whether there is a way to tell the system to link specific bioenergy pathway, basically leads to a specific bioenergy product, to its correspondent comparator in terms of traditional use that need to be done for power production as well as heat, and then because we already had the one for liquid transport fuels. So we cannot, at this stage, I do not know whether we will be successful in doing this by the end of the project, which is October, but let's say we've already under our radar this problem, yes.
Yeah, thank you very much, Alexandra, again for your question and for the answers. Actually, I found under the Q&A a very interesting question to our FAO colleagues coming from Ms. Lasdina. Seems that due to global warming, FAO zoning maps should be revised. That I think is that could keep you busy at FAO for a while. No, but I assume that you're working on that. Could you, I'm not quite sure whether this is, you can answer the question, or you can give us an update what actually is done. No, but obviously they are talking about growing wine in areas that they haven't before, or let's say I do believe quite some changes will occur there.
Yeah, no, that's a very good point. And in fact, the guys already include, guys being the reference system we use for suitability and yield maps, already has different future scenarios that work with different global warming, let's say, thresholds set. So these different scenarios were future projections that we decided not to include as of today, because these are scenarios, so that it would have complicated very much the way we would calculate our sustainability indicators every time. So because we didn't feel as producing too many scenarios and including too many scenarios and therefore too many layers, we restricted ourselves to the latest available one, which though covers up until 2010. And therefore, there might be differences. In fact, there might be need for updating and checking whether, in reality, the scenarios adhere to the reality of things in terms of yield suitability. But this is a bit against, outside the scope of Bioplat EU, as instead it's, let's say, the job of the guys, colleagues at FAO. But definitely we have taken that into account. And to work out an alternative, we always allow advanced users to change the suitability of a certain crop and the related yields. So that can be done regardless of the scenario or out of whatever other need the user may have. But it's interesting to say that it could be useful to then think down the line. So let's say in 3 years from now, what if the new guys' suitability layers are out there, are available and are updated? Can we simply swap them with the ones we already have and basically update also the suitability maps for Europe, which might appear differently than what it is today? So yeah, that's a good point.
Just to clarify, Marco, so you were using suitability maps from 2010, no? This is what you said?
Right, guys, version 3 was the last one we could access to, and those suitability maps use data until 2010. But then they have future projections that look up until 2040, if I'm not mistaken, and even 2100. But we did not feel like using those projections for the reason I explained.
Okay, no, it makes sense and understandable. You can't have this tool under different scenarios. That would be too complicated, certainly. Any further questions? Please. Okay, yes, here we go.
Okay, I was just thinking about when we're talking about future use and future scenarios, we see a lot on these integrated assessment, circular economy. How do you think it would be to include not only the bioenergy use on one patch of field, but to use it together with some material use like residuals? I think we discussed it in very early, and it was not part of the Bioplat EU, but it could be an interesting point for the future to say, okay, if we grow wheat, the straw could go into bioenergy use, the wheat could go into food, something like that. Maybe there are some views on how this would be usable in the future. I don't know to whom, whoever thinks this could answer.
This is an open question for the panelists.
Yeah, I agree with you, and we actually have straw in the tool as one of the feedstocks. But yeah, we have the discussion before, and of course it could be for the future a good way to expand the tool. Yeah, also to consider chemicals, for example, as output, but also different residues for the production of the bioenergy. Sure.
No, I would also believe, I think that could be a very nice potential addition to not only look at the energy use, and certainly the concept of circular economy or generally more resource efficient economies, that will continue to be a hot topic, but then we shouldn't claim that we can solve everything with one map. But certainly keeping circular economy phrases in mind for everything we do actually is certainly a useful thing.
Yeah, absolutely. And this is a tool. I mean, we have to remember that this is a tool for marginal lands. So of course, the production not present. And maybe a way could be the integration of residues from other places, other production with the biomass produced on this lands, underutilized lands. This is circular, of course. Could be a further development of the tool.
No, again, I think it is, all these are interesting further aspects, but then in order to be practical, of course, somehow you have to simplify reality in one way or another. And just to bring back to mind, like the project was trying to compile information on these MUC lands, which are high on the agenda, but not really extremely well researched yet, or even the definitions are still controversial, and we found that countries have different levels of contamination thresholds, and so let's say it's still. And then even with respect to the use, now basically what we assume that MUC lands can be used, no, because they are not very suitable for food, but then there is also other potential uses, like non-use, for instance, for these MUC lands. So it doesn't really automatically mean that all these hectares that we have identified that comply with sustainability criteria immediately will go into future use. You know, there is, but basically I think what we have provided is to move forward the whole discussion about the potential availability of MUC lands in Europe, you know, and especially as Manuela presented initially, basically this way how to use remote sensing to identify. This I think is even though it's also, this is not 100%, as Manuela showed, you will still have errors in this field, but it is it makes potential analysis on a broader scope possible, because otherwise you need to visit every square meter, you know, and then and ask people whether they are active or not, and even then there might be not 100% reality, if you listen to farmers there. Any further questions? And actually, I think Manuela and me, we are playing this up and down game rather well. So because I had prepared a question for her, and actually I was interested in how the remote sensing community is uptaking basically this approach to apply their results to the identification of land. And yeah, I agreed with Manuela to ask this question, and now I will ask her to respond. Kommst du mal, gell?
It's always good to move, keeps you awake. Okay, so thanks for the question. The thing is, there was at some point after the downfall of the Iron Curtain, there was a lot of interest in abandoned farmland. So this was at this point, like in the early 0 years, something like 2005 around, there were some studies on these abandoned agricultural lands in these Eastern European countries. But it was at that point, we didn't have the time series data available. So what it was only a comparison of an image from before and after. And there were a lot of insecurities, or there was very coarse data, which could only give like similar to statistics, like values of hectares, but not really focus on a specific area. So that was in the past, and only now that this time series, this high resolution time series become available, is that this is coming more into focus. And as far as I know, we have been now the first to move this really in an operational level to map this kind of underutilized land. What is currently very much interested and also studied is like things like mowing circles, intensity of grassland use, also related to the Green Deal, related to the biodiversity issues. So that's something that's in the remote sensing community quite a lot that we try with this time series data to detect how many times a certain plot is cut in terms of grassland. So it's an extensively used or intensively used grassland. But that's something that goes along this line. But to my knowledge, really this focus on underutilized land, at least to my knowledge, is not has not been done. But I hope that we, with our publication, that also it's a bit further distributed and disseminated, and some more people will see the potential of remote sensing also in this frame.
Thank you. I can actually, with respect to the MOOC lands, I have to admit that I'm not 100% sure how they will be treated under the new RED 2. Is there any of you in the audience or in the room here who has more? Will they be will they receive any specific support, or will there be multiple counted? I think because it wasn't in one paper, they hinted at some special treatment. No, because I remember that some measures for promotion of MOOC lands were being discussed. Now, okay, sorry, I cannot be more concrete here. Does anyone know?
I know it was under discussion, but
okay.
I don't know whether they get to a final target or final idea on that. Yeah.
This is interesting for Manuela to answer.
Okay. A new question has arrived.
Yes, and this I think Manuela would, because we did check the magic projects and.
Okay, that's there.
So I'm coming again. Sorry. Okay. So thanks for the question from an anonymous.
I don't know who, but
whoever. The question, I don't know if everyone can see it. I will read it out anyway. Have you cross-checked the results from your project with those from the MAGIC project that aims at a similar objective? Yes, of course we did. But the MAGIC project only looked at statistical figures on I think it was provincial or municipal level, so not local administrative units, but even the broader ones, so like provinces. So they summed up, and you can see it on this on the website as well. So you can see maps of percentages of marginal lands, for example. But what they included was also all the marginal lands. That means, just for the example of Austria, where I'm from, we have huge amounts of marginal lands, but these are the mountains. So you cannot grow any crop in a way like we considered it in the Bioplat Eu project there, because it's 2,000 meters high or very steep or very rocky. So they included all of this. That was not, and it was only statistical. So what you have a map, but the map is only per statistical unit, per administrative unit, you get a number. So you cannot zoom down or zoom in to a certain patch of land. And that's the main difference to this MAGIC project. And while I'm talking, I'm also saying something about the SIMLA project, which is another initiative which we also reviewed. It was, in a way, it was not statistical. It means we had real areas with the SIMLA project, but it did not take into account the current land use. So it was marginal land. But for example, if you have marginal lands, like in southern Italy, with a lot of olive groves on it, so the land is marginal, but the land is used. So you cannot come here and say, okay, let's cut all the olive trees and put some whatever giant reed there. It's, of course, this is nothing that can do. That what we tried in Bioplat EU to get rid of these problems, which we saw from previous initiatives in this way. So that does not mean that these results are not good. They just have a different focus and a different purpose.
approach.
Yeah.
Okay, if I
your answer, you were asking about the red too. Someone answered.
Yes, there is a consideration from Asta in the chat. Maybe I could read it live. So Asta was saying the relation of marginal underutilized contaminated lands and RED 2. Here is her consideration. In relation to low ILUC certification, the marginal underutilized contaminated lands would naturally fall under the category of not trigger for indirect land exchange. So food and feed crops cultivated in new lands could be certified as low ILUC and then get freed from under the crop cap.
Okay, as certified as low ILUC. And I found, I apologize again for not being sufficiently well prepared. What I actually read is that there is being discussed a so-called degraded land bonus criteria. And now I read another thing where I don't know whether this is true or only being discussed, as Lorenzo was saying. But I will read it to you. For that, I need to take a class. Okay. When calculating the greenhouse gas emission savings of biofuels in comparison to fossil fuels, those produced from feedstocks on underutilized, abandoned, severely degraded, and heavily contaminated land may be eligible for a greenhouse gas emission savings bonus, calculated as an emissions reduction of 29 grams CO2 equivalent per megajoule, provided that a steady increase in carbon stocks as well as a sizable reduction in erosion of land are ensured. Okay, good. So there is a two caveats, but actually also if such a bonus would come, then a number of value chains might still be eligible might meet the threshold of greenhouse gas emission reductions. Of course, this is all still under discussion, but if such bonus and also this freeing from ILUC could come into place, then certainly the interest in MOOC lands would remain high. This is that was basically, I think, the statement from Asta's clarification and what I just read, even though we don't know the exact details. Meaning that what we have done made sense. Okay, then this is always good to know. Yeah.
And Asta was adding in the chat that the degraded land bonus was also in the old RED, but it was not used so much. As the criteria has been unclear so far.
No, basically, if what I just read was the criteria, then it's really unclear. No. Yes.
Rainer, I don't see any other question unless someone in the meeting room has any additional question. I leave it to you being there.
No one. So maybe Michela, should we proceed with your synergies talk, and then we can, if won't be critical if we stop a little earlier. So if we have discussed
Sure.
everything we want, we'll just close.
Thank you so much. Indeed, this is a very good opportunity to stop and consider and think aloud in light of the discussions that we've been having today in these workshop, and also all the challenges and opportunities that the WebGIS tool offers to users. So from the discussion of today, I have a few, let's say, take-home messages in terms of synergies with the Global Bioenergy Partnership. We all know that because of the membership of the Global Bioenergy Partnership, with around 80 members between partners and observers, between governments and international organizations, We may be, and we are in a unique position in terms of supporting EU and non-EU countries towards a shared vision of bioenergy for a sustainable future through international cooperation projects and activities. So even the consideration, a common consideration of sustainability is extremely key, and it's not to be given for granted. So that's my first point. Then on one side, GBAP can contribute to inform bioenergy policy development at EU level on the best use of and potential application of the WebGIS tool as a means to facilitate sustainable development of bioenergy and achieve the targets of the RED II. We could do this as an initiative through our technical bodies, which is on one side, the working group on capacity building, and on the other side, the task force on sustainability, which are both very much focusing on sustainability as a key aspect of our program of work. In addition to these, of course, we are happy to participate in new projects in order to give more visibility to the GBAP indicators and to their application, like in the case of the FORBIO and in the case of the Bioplat EU project in terms of potential applications of the sustainability indicators. Well, on the other side, GBAP is also in a unique position to act as a catalyst platform to expand the outreach of project results and lessons learned on sustainable bioenergy through our expanded membership beyond EU and mainly at the global level. And this is also somehow connected to what we mentioned before. I mean, the brainstorming that we had before in terms of, let's see if GBAP, now that we'll start a cooperation with the BioFuture platform, there may be opportunities to give visibility to the WebGIS tool that was developed, that is being developed by the Bioplat EU project, and maybe being applied and consider possible application and replicability in other countries. So that's another way that I see as a potential synergy with the GBAP program of work. I also would like to add that from what I've heard today in terms of case studies, application, and also application from Neste colleagues, well, the Bioplat EU project has demonstrated how the science and the methodological approach of the GBAP indicators can be applied to foster sustainable bioenergy developments on marginal, underutilized, contaminated lands in Europe. And these open up, of course, the idea of replicability in other contexts, and as well as applying this with different land categories to meet the needs of countries, for example, in Latin America, of course, with all the challenges also in Africa and Asia concerning bioenergy, sustainable bioenergy as well. Well, all these activities that I've mentioned could give the opportunity to give visibility and dissemination of the results of these important Bioplat EU project with a view to further inform bioenergy components of future consideration of the EU directives on renewable energy beyond 2030. So this is, in a nutshell, a few considerations in terms of how I see a synergy, a concrete synergy between the results of the Bioplat EU project and the WebGIS tool that has been developed and future activities of the Global Bioenergy Partnership. And of course, I'm happy also to open up for questions, if any, from participants within and outside the GBAP family. Thank you, Rainer.
Yeah, thank you very much. Thank you very much, Michaela. No, thanks for broadening this view. I think we said initially when we wrote this follow-up proposal of the FORBIO, we said We will take the same approach that at the end of the project, we will all come to Rome and then storm the FAO building, you know, and have a meeting there or link up with one of the DBED meetings. Now we all know that the pandemic came, you know, so we had to change plans. But this international dimension and the linkage between the Bioplat EU sustainability approach and the DBED sustainability criteria, I think is highly valued and needs to be underlined, and might open up opportunities in the future. Also, Michaela, what you were saying, your new the new cooperation with the BioFuture platform. This platform, I think, is more industrial. I think you mentioned yourself, or has a stronger. I'm not 100% sure. Yeah, no, you're saying yes and no at the same time, you know. But I believe that tools like Bioplat EU could, like what we were hoping for, is that now interest also of the private sector, of people who might be implementing the value chains would come, you know, and I believe that in the coming month of the project, we will not be able to do too much, you know, but we can continue even after to use all channels to promote the tool for actual users. Alfonso mentioned before. Now we want users to get the hand on the tool and help us further develop the tool. What I can maybe say that the provision of sustainable raw material for biofuels within the whole bioeconomy and in the overall circular economy will remain to be an extremely hot topic. And the question, as I mentioned earlier, is how much can we use MOOC lands? Should we leave them alone? Basically, what I said, you know, or can we really provide some of our resources on such lands that might not be suitable for food production? This will continue, I think, to be a hotly debated topic. And basically what we probably all know and what you have seen is that quite a number of also large players, they are intensively looking into the feedstock availability. Now there was like the potential to produce sustainable feedstock for different applications. Not too long ago, actually, there was a study published by CONCAVE, which is the Association of European petrol companies, like with all Shell, Totals. I think probably Neste is also a member. I'm not 100% sure. And they were commissioning a study about the biomass potential in Europe. No, because all these large companies, they know they need to broaden their feedstock base. And now maybe Lorenzo, can you also make Asta a presenter, that she, at least I could invite her to say a few words coming towards the end of our workshop, because I believe, let's say, the scientific part is one side, and we have seen that Manuela has also underlined from the science perspective, the project made good progress. Also, the platform extremely well developed. But what we want actually is we want the interaction with the society and with the industry towards implementation of such value chains. And as again said, the feedstock base needs to be broadened, and we might need to include these MOOC lands also. And for this, they will certainly be interesting for instance, large oil and fuels companies. Asta, I see that. Would you want to say a few words from the industry perspective, how you believe such a tool? You have given a presentation at our internal meeting. Many thanks for that. It was also very positive, of course. That I think would make us all happy. Could you say just a few words? Yes, thank you very much.
Yes, sorry for all the commenting on the chat box earlier when I couldn't speak. But yeah, well, as I said earlier, that we are really happy that we have been involved in this project and learned a lot. And we see that after testing, during the few last months after testing the tool and testing the feasibility and the potential of European MUC lands, that there is potential, and we find that this sort of tool is really useful for finding them, and also building value chains, or at least parts of the value chain. So I don't know if you wanted something else. Also, I can comment on the like more regulative perspective that I was also chatting there. That I see that there's really like a kind of order for this kind of tool, that the Commission can really utilize the potential of European raw materials and get rid of the food and feed crops. So this is necessary to utilize this degraded land bonus, and then also find the low ILOC risk potential in Europe, within Europe.
Cosette muted me, which is not a bad idea usually, I think. So many thanks, Asta, for that intervention. From my point of view, I think we could close the workshop with this, unless maybe with some farewell remarks from Michela. I believe what we have seen is we have a well-functioning tool. We are addressing the right topic, which will continue to be interesting for researchers on the one hand side, but also for industry. And I think this is good news if there is a good cooperation between those two, and also the interaction with the local communities, of course, and what we are trying in the project. Of course, let's say what we need to keep in mind, just as a last caveat, is that obviously this tool will never come up with will never be a cash machine. Where basically the euro come out. So it is a first start, and based upon that, you could start developing your value chains, interacting with the local stakeholder, making the contracts with the offtake contracts, the feeding contracts. So this will not be covered by the tool in any. No matter how good the tool is. Sorry, David, but we need to be realistic. But I believe that we are very close to what a tool like this, that is open to all, that is free to use, non-confidential, can deliver. I'm rather confident on that. Michela, would you want to say some very final words, and then we could close? But we would invite the project partners so we would close the international workshop, but we would invite the project partners to also wrap up our meeting from this morning, which we didn't manage in the morning.
Thank you very much, Rainer. And indeed, I just for some closing remarks, I completely agree with you that we are satisfied, happy, and proud of the result of the project, in particular for the tool that represents a concrete support to decision-making in the bioenergy sector in Europe, and could be used also an example for other applications to achieve the requirements of the European directives and address policy support also in other areas. I mean, I really see the potential for future applications and replicability. Well, allow me to thank WIP as coordinator of the consortium and all partners for the very positive and constructive collaboration. Rainer, Cosette, all the partners and colleagues that are there with you in the wonderful Matera, CREA for organizing this gorgeous event in person in Matera, and it has been a long-lasting 3 years. When you work a lot, I mean, days and years never passes, because you put a lot of efforts on each step of the activities. But it's always good to sow the seeds and get out excellent results from the project. And as a final word, allow me also to thank colleagues connected today from the GBEP family and other experts and participants that also contributed to our discussion today. It's always a pleasure to discuss and exchange views and highlight challenges, opportunities, and find ways to best apply ideas together. Thank you very much.
Thank you.
Yeah.
Thank you to all partners.
Yes.